All right, welcome to Chapter 13. It's our last chapter of the year. We're going to talk today for Section 13.1 on simplifying radicals. Go ahead and make sure you fill in today's date so you know when you're working on this. All right, first thing, we're going to talk about our steps here to simplify our radicals. So we're going to make a factor tree. And just to remind you, a factor is things that multiply together to get to a number. All right, and then at the bottom, when we're all done finding all the factors, we're going to find pairs. And this is going to be, oops, I don't want the marker anymore. I'm going to find the pairs of radicals. So find pairs at the end of the branches. You'll see a little bit more what we mean when we talk about that. And then we're going to write pairs and leftovers. Write the pairs and the leftovers. Write the pairs out and the leftovers go under the radical. And that's that square root. And then we're going to simplify if necessary is our last step. So you'll see what I mean when we start talking a little bit more and going into more examples. Our example right here in the box, we're going to simplify 108. So I'm going to make a factor tree. So right off the top of my head, I know 2 times 54 gets me to 108. We're going to stop at the end of our factor tree when we have prime numbers. Remember, prime numbers are numbers that can only be multiplied by, only have factors of 1 in itself. 54, I know, is 6 times 9. 6 is 2 times 3. Those are both primes. And 9 is 3 times 3. And again, those are both primes. We're going to take out the pairs. So I see a pair of 2's. Multiply that by the pair of 3's, and then that leftover 3 is going to go under the radical. So this simplifies to 6 square root of 3. I'll write that up here as well. All right, so let's do some more practice on this. We're going to do our factor trees, and then we're going to simplify what we can. Okay, so let's move down here to 49. So 49, if we start breaking that down, I know is 7 times 7. So this is my pair that comes on the outside, so my answer is 7. The other thing that you could recognize for this one is it's a perfect square. Perfect square number, so you could go right to that answer of 7. All right, 64, if you recognize that as a perfect square number, we know our answer is going to be 8. I'm going to show you how that works in factor trees. I know this is 8 times 8. I know I can break 8 into 4 times 2 and 4 times 2. Notice how I circle my pairs. Then I know this is 2 times 2. There's another pair, prime number, and 2 times 2. So my pairs come out once. Another pair comes out once, and another pair comes out once. So 2 times 2 times 2 is 8, which we already know because 64 is a perfect square number. All right, moving on to the next example here. I'll try and separate my colors here. So I've got the square root of 12. So thinking about factors of 12, I'm going to go with one that I know. I'm going to go with 6 and 2. Now there are other ways to start this as well. So I could have chosen 3 times 4. I could have chosen 2 times 6. I chose 6 times 2, same thing. I'm going to circle 2 because it's a prime number. Finish up with 6. I've got 3 and 2. Both of those are prime numbers. I'm going to take out my pairs once, so that's going to be 2 times my non-pair, or my leftover, which is the square root of 3. So the square root of 12 simplifies to 2 square root of 3. All right. Let's do some more practice here. This is really good practice on our factoring. We're finding things that multiply together. Eventually you might get pretty quick at this. Maybe see bigger perfect square numbers first. All right, so 32. Let's work on breaking down 32. Let's pick a different color here. All right, so 32. I know I can multiply 8 times 4 to get to 32. There are other options. They all get us to that same answer. 8 breaks down to 4 times 2. 2 is a prime. And then 4 is 2 times 2. This 4 breaks down into 2 times 2, so I can factor that. Now I have all of my prime numbers. I'm going to take out my pairs. So I have a pair of 2's and another pair of 2's, and this 2 then is a leftover that goes underneath my radical. So my final answer is 2 times 2, which is 4, square root of 2. Now I want to show you something really quick on this one. I'm going to pick a different color here. If I chose to break down 32 into 16, I'm going to change this to the square root of 16 times the square root of 2. I can recognize that 16 is a perfect square number, so I can take the square root of 16, that becomes 4. Can't do anything with the square root of 2 except write that down, so I just wanted to show you kind of another way to think about that. I can find that perfect square number that I can actually take the square root of. That's going to come out. That simplifies. And then I would change that to square root of 2. All right, looking at 75 here. Let me get a different color so we can keep everything separated. All right, so 75, I see 25 times 3. I've got a prime number there of 3. See 25 as being 5 times 5. Circle my prime numbers here. Take out my pairs once, and then I'm going to multiply it by the leftovers, 3 under the square root, which is 5 square root of 3. Just kind of a note here, this 25 is a perfect square number. Notice how that 5 came out. 5 times 5 is 25. Something to start thinking about here. All right, moving on to our next example here. Pick a different color. All right, so when we see something that looks like this example right here, we're going to first take those two radicals, or square roots, and we're going to multiply them together. So the square root of 3 times the square root of 6 is actually the square root of 18. All right, now I'm going to break down or reduce that, or do my factor tree for 18. I'm going to go with 2 times 9. 2 is a prime number here. Break down 9 to 3 times 3. All right, I see my pairs of 3's are going to come out once, and then that leftover is going to go underneath the square root. So square root of 3 times the square root of 6 simplifies to 3 times the square root of 2. All right, moving on to the next, more simplifying of square root times the square root. So I'm going to first multiply those together. So 5 times 15 is the square root of 75. If you recall, we just did that one. So I'm going to break this down into the square root of 25 times the square root of 3. Square root of 25 is 5. Square root of 3 is that leftover. Again, we just did that one. Remember, 25 goes into 5 times 5, which is where that pair comes out. All right, square root of 21. So first thing I'm going to do is multiply those together. Let's change colors for you. So this, 3 times 7 is the square root of 21. Breaking that down, I get the square 7 times 3. Both of those are prime numbers, so those both go underneath the square root. So my final answer here is actually just the square root of 21. That is as simple as I can get it. All right. Okay, so now we're going to simplify some fractions here. Pick a different color here. So we're going to do this top and bottom. We're going to simplify the top first. I see that 9 is a perfect square number, so I'm going to actually take the square root of 9. So the square root of 9 is 3. And the square root, I look at the bottom, I see that 25 is also a perfect square number. So I know that my answer is 3 over 5. Another way to look at this is taking 9 and breaking it down into 3 times 3. That's where those pairs come out one time, so I've got that there. And then 25, breaking that down or factoring that, I get 5 times 5. There's my pairs, it comes out once, so I know 3 over 5 is the best answer I can give you. Alright, last 3 examples here. This is called rationalizing the denominator. In math, we cannot have a square root in the denominator of a fraction, so we're going to do what's called rationalizing the denominator here. So when we're doing this, we're going to actually look at the bottom number here first. So I'm going to try to get that radical out of the bottom. In order to do that, I'm going to multiply this fraction here by the square root of 2 over the square root of 2. So we're going to look at getting this denominator rationalized. So when I do that, I have the square root of 2 times the square root of 6 on the top. That becomes the square root of 12. And on the bottom, I have the square root of 2 times the square root of 2. So if you recall that, when I have the square root of 2 times the square root of 2, I get the square root of 4. Well, 4 is a perfect square number, so my answer is going to be 2. So now I've rationalized the denominator. I've got 2 in the denominator, so I'm getting rid of that square root in the denominator. Now I have to look at simplifying that radical on the top, so I'm going to take 12 and I'm going to find my factors. So I've got 4 times 3, 2 times 2. Taking out my pair, I've got 2 times the square root of 3 for my numerator then. So let's go down this way. So 12 turns into 2 square root of 3 over 2. Knowing what I know about fractions, 2 over 2 is the same thing as 1. So my final answer here is just the square root of 3. Started off as something not real pretty, square root of 6 divided by the square root of 2. Changed into something pretty simple, it's the square root of 3. Alright, next practice on rationalizing the denominator here. I'm going to do the same thing. I'm going to multiply the top and the bottom by that square root that's in the bottom. So I'm going to take the square root of 5 and the square root of 5. So I'm going to multiply through here. On the top I get the square root of 35. On the bottom that becomes just 5, because again, square root of 5 times the square root of 5 is just 5. 5 times 5 is 25. That's a perfect square number. That turns into the square root of 25 as being 5. Looking at square root of 35, I know I can break that down into 7 and 5, which are both prime numbers, so those would stay under the square root. So there's really nothing more I can do to this one than just keep that as a square root of 35 over 5. Alright, and the last example here, change colors one more time. I'm trying to get that square root of 14 out of the denominator, so I'm going to multiply the top and the bottom by the square root of 14. So on the top I get 4 square root of 13 over square root of 14 times square root of 14 is just 14. Then I'm going to look here and I'm going to look to reduce my fractions. I'm going to look to reduce this 4 over 14. So I know that 2 goes into both of those. 2 goes into 4 2 times. 2 goes into 14 7 times. Let's fix that. And that square root of 13 is simplified as much as I get. 13 is a perfect square number. So 2 square root of 13 over 7 is my final answer for that one. So again, this is lots of practice on factoring and finding numbers that multiply together to get to the number we're looking for. First assignment here for 13.1 is just a worksheet. You'll find that on the next page.